Hello class. In this video we introduce a new kind of data structure called an array. Up until today we've been looking at single primitive data types such as integers and floats and characters. And you can see that a variable essentially is a location in the computer's memory where a value can be stored. The variable's name references that memory location. So in a sense, a variable is a pointer to a memory location. And you can see by this little example here, the variable has the value 0 and it has a single value. Well, a list is a little different. An array is a list of variables and they can all be referenced by the same name. So you can have a list of items stored in a list or an array, and each one would have its own element in the array. So each of these little boxes here are called elements, and you access them by giving it an index value. Now, similar to what we saw in strings, and in fact you can think of a string as an array of characters, an array is accessed starting at element position 0, going up to element position 7. So again, we always start at 0, and in this particular example, this array has 8 elements. Items 0 through 7, 8 would be out of bounds, and we saw that error in a prior video when you try to access an array with a value that is out of bounds. In some programming languages, you can have a list or an array with multiple data types, meaning you could have integers and floats and strings and characters all in the same array. Java does not allow that in the array data type. So for every array, you must define it as an array of a specific data type. And we're going to look at what those are that we can use and how we can define those. In this example, we can see it's an array of integers. For now, we will focus on arrays of primitive data types, but in essence, an array can be of any data type at all. So how do we declare an array? Well, first we declare it very similar to how we've done any other variable. We have to give it a name, and we have to give it a data type. Here we see that the data type here, int variable name, declares a single variable, such as we've always used in the past. This next item here declares the array, and you can tell it's an array by this square bracket notation. So the square brackets are what tells Java that the variable we're defining, array of ints, is actually an array. Now this particular statement just gives it the name. It does not create the array. That comes in the next part. Think of the scanner that we've used already. The scanner, when we created the scanner, we gave it that new functionality. In fact, let me go over to the lab area and I'll get that loaded up so we can take a look at it. One thing I've also been doing recently is opening it in a new tab, because you get a little bit more window to work with. So I'll be doing that going forward. But if we wanted to create our scanner, we would give it the data type, scanner, a variable name. We would use this new word. We give it scanner again. Well, this is how we declare an object and how we instantiate an object type. Well, arrays are very similar to objects, and we're going to use that same new constructor to help us build the array. So we could have done it two ways. First, we can let's create an array, first of all, similar to what we had in the first slide. Array of ints. And that's our array. We've created it, we've declared it, we haven't done anything with it. It produces no output, it doesn't do anything. The next thing after we create the array, we'd want to initialize it. And we can see here, we can give it this variable, this statement here, array of ints equals new integer array, 10 positions. So we could try that. Array of ints equals new integer array in 10 characters, or 10 positions, 10 elements, sorry. And I can run this to make sure the syntax is correct. And it did, and it produces no output again, which is fine. So that's one way of creating a 10-position array. Not often done like this, but you certainly can. More likely, it is done in a way like this, where you do it all in one statement. Declare and initialize all in one statement, similar to what we've done with the primitive data types. So I'll copy this statement here, and I'll paste it in here. And I'm going to give this one array of ints 2, so we don't have conflicting data names. And if I run this, we'll get the same no output, but now we have 2 arrays, each with 10 positions. Now, as you may have seen in this slide, you can also put the the square brackets, instead of on the int, on the variable name. This also works, but it's not the preferred method of doing it. It makes it much easier to read and understand code when you see the curly brackets on the data type, since you instantly know it's an array. It's also a good idea to name your variable with either array or list or something along those lines, so you can tell by looking at it that it's an array. Now, we talked about integer types, and you can declare arrays for floats, and you can also declare arrays of strings. So you can declare an array of just about any data type. We're going to stick with primitive types for the most part. Okay, now that we have our arrays declared and initialized, we need to do something with them. Well, first we need to understand how we can access an array element. And using our syntax here, we can create a new temporary variable, and we'll do that. We'll create a temporary variable, just an integer type, set it to 0, and we'll go back to our code or our slides, and we'll see that we can access array elements by giving it the variable name, the square brackets, and then this number. The number is the position in the element in the array that we want to access. So if we said 5, if we go back and look at our chart, 5 would be this position, starting at 0. So it would not be the 5th element in an array. Technically, it's the 6th element in the array. So 0, 1, 2, 3, 4, 5, which is really position 1, 2, 3, 4, 5, 6. So it's always starting at 0. I'm going to keep repeating that a lot of times. So if we wanted to access this value, this is the statement. And this is treated like any other integer variable because it is an integer variable. Even though it has an array index and a subscript, it is an integer type. And we can set that to, let's make it match the code or the slides. And we can even print it out. And we'll get some output this time. And we'll just print temp_var to have something printed. And what would you expect? So before I run this code, we should expect something. What are your expectations? Well, again, like any integer variable, when you don't assign it an initial value, it gets a value of 0. So we gave it the value of this 5th in the element number 5, well, 6 technically, but 5 counting from 0, that it's assigned to temp_var, and it gets the value of 0. Because we have not initialized and given it any other values other than creating the array, so by default it gets 0. Now we can assign values to it in several ways. We can assign them one at a time by simple statements such as this, which is good for very small arrays. So if I had done, let's initialize the array here. Let's put some values in it. Ints of 0 equals 0, array of ints 1 equals 1, and we'll skip a few and go right to 5 because we're using that already. And we'll have 5 there. So now my expectation when I run this, I will see the value of 5 print out. And I do. So you can assign values individually, one at a time. Good for small lists and small arrays, but if you had a rather large array, that could be pretty tedious. Another way of doing it would be to assign these values all at once using this kind of syntax. And I'm just going to copy this. And we'll assign that to the second array. And we'll give it this curly bracket notation with all the values listed out. 1, 2, 3, 4, 5, 6, 7, 8, 9. I need one more. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. I need one more. And if anybody's familiar with the sequence, you should know the next value is going to be 34. So if I went to initialize the array this way, let's create a second temp var for accessing the second array. And we'll take item number 8, and we'll print out temp var 2 instead of temp var. And I would expect to see element 8, which would be 0, 1, 2, 3, 4, 5, 6, 7, 8, which should be 21. And I have an error. Let's see what this error is. Semicolon expected. That's interesting. Okay, my mistake. I see what I did. This is a way of declaring an array and giving it its size originally. So we don't need this new construct here. What we need to do is this. We would list out all the values immediately, and that would build the array of the exact size we want. So we don't need this statement here. So let me get rid of that altogether, and that should give us a better result. So yeah, so the difference here is this way we don't need to tell it how many positions there are. We're flat out listing them out, so we have the entire array defined for us. And there's the 21. So it's a little different. Again, it's great for small lists when you have a known set of values that you want to start with. So you can use that as necessary. But what if you had a rather large array? So let's create a new array. We'll give it a float. And we're going to temporarily get rid of this print statement because we don't really need it right now. But let's say we had an array of floats. So we could do float, square brackets, and we can call it float array equals new float. And what if we had 1,000 values? So 1,000 values is a lot of values to try to populate by hand one at a time. You would need 1,000 lines of code here, or a big, long, comma delimited list here. Not ideal. So there are other ways. So let's take a look at those other ways. We can use loops. So one thing to think about, whenever you're thinking about arrays, you should be thinking about loops. A loop is the perfect tool to access elements in an array. And there is a specialized version of a for loop that we'll see later on that makes arrays even easier to deal with. But for now, let us take a look at this code here where we can populate the array with, and we'll just use random numbers. And I'm going to rename my variable in the example from float array to random numbers just so it matches the slide. And then we'll try to implement this code so we can populate that random number array with different values. So we're going to change float array to random numbers. And then we'll go ahead and build our loop. So in order to do this, we need to get our random number utility imported. So we'll import java.util.random, which we've seen before. And we'll go ahead and create our new random number object. Like that. And now we can go ahead and start populating our array. Well, first we need a loop, and we can either use a while loop or a for loop. we'll start with the while loop, and then maybe we'll migrate to a for loop later on. So first, if we're going to use a while loop, we need to use we need to set an iterator variable. And we use n. We'll set it to 0. And then we can simply do while n is less than 1,000. So we never go to equal 1,000. It's always less than 1,000 because it starts counting at 0. And we can now build our random assignment. And we can access the array, random numbers. And now we have to give it the index. And that's what we're going to put inside the square values. And since we want to populate every position in the array, we want to use the loop variable. Start with n. Since n is 0, we'll start with the first value of the array. And then we want to give it the value from our random number, which was rndm. And we want to get the next floating value. And then we said we want it to be between 0 and 10, so we can simply just multiply it by 10. Very simple math. And that will populate our array. However, we still need to do n equals n. Well, we can do n plus plus. Now, I'm going to comment out this. I thought I did that already. Comment out this, and we will now print or populate our array. We'll see if it runs, and it does not. It's giving us a error, and that's because I forgot to put the s in random numbers instead of random number. And there, okay. So it did populate the array. We think, we don't know, we haven't seen it. We can simply do a print if we want. Random numbers. We could use n again. And we just print out every value as it goes. I'm going to temporarily just change this 1,000 to a 10 because I don't want to have 1,000 lines of output. 10 should be sufficient for this example. And again, I left off the s. And I'll run it again. And there are my floating point numbers that are all randomized and stored in the array. Great. So you can see you can use an array, a loop, to easily populate an array. If you wanted to instead use a for loop, we can do that. So remember, you preset all the values up front. And now it's a simple matter of just random numbers. And this time we're using I as our loop variable. And we'll take this one times 100. We'll give it a little bit bigger values. And we can do a system.out.println random numbers of I this time. And again, we'll drop it to 10 for a second, just so we don't get a lot of output. And again, I spelled it without the S. And we'll try it again, and there are our outputs between 0 and 100. So you could see we can easily populate the array with a loop, and in this case, random numbers. And I'll reset the values to 1,000 so we have it complete. Okay, so one thing you'll notice here is that we hard-coded in the value 1,000. Not a fan of hard-coding values when we can use variables to hold our places. So let's create a new variable. We'll call it int array size, or size of array equals 1,000. So we can instead now change this 1,000 to size of array. And now we have a little bit easier mechanism of updating the size of the array should we want to make a change later on down the road. We just need to update this one variable. But you'll also see now down in the loop, we have the 1,000. So we could do a couple of things. We could do size of array. And that would work if we knew what exact array we wanted to use. If we have multiple arrays of different sizes, this might be an issue. A better way, and I'll leave this in for now for comparison, we can use something called the length property of the array, which is not a method, it's a property. It's a little bit different. So it doesn't get the parentheses at the end like a method would. It just gets the dot notation. So we'll write it out as random numbers dot length. So the length of the array is 1000. That's the property. The property tells you the length of the array of 1000. So we can do this, and if I run it, it's going to say produce no output or give me an error. Yep, because I, again, forgot the S. And I'll run it a second time, and now produce no output because I took out I'll uncomment it and try it again, and we'll see it print the values. It did print 1000 values. It did not want to do that, but that's okay. So you could see we could not have to hard code the length of the array. We can use either the property or a defined variable size. Now, one thing you might want to do and consider is making this a final value, meaning we don't want to change its value once it's been set. Once you have the array size set, you don't want to change it or affect it, because that could make your code fail if the loops don't execute right with the right endpoints in with the elements. So that's something to consider as well. So let's jump back to our slides and see where we're at. We only have a couple to go. Okay, this discusses the length property, which we just talked about that. So the length property, again, it allows us to identify the length of the array without hard coding a value. So here's an interesting example. We have two arrays. We have a string array and an integer array. And we see in the string array, we have a list of states: California, New York, Georgia, so on and so on. And we have populations of those states in a second array. Well, if we know that these arrays are in the correct order, meaning California is always position 0, and the population for California is in position 0, and so on for New York and Georgia, we can use a single index to reference both of these arrays to get our data. So the question is, how can we print whatever the state's name is has a population of whatever the state's population is? Well, we can first copy this code. We're going to need to, well, let's see if I can copy it all at once. And we'll put that into our lab. And we'll put it after the for loop, and I'm going to comment it out so we don't have all this printed at first. And we'll make it look nice and organized. And we'll do the same for the populations. And let's say we want to know the population of Alaska. And we'll start our print statement. So the population of Alaska is, well, where is Alaska in our states array? It is in element 0, 1, 2, 3. So we will print out states 3 as a population of, and we can now see we need to use 3 again. We need to use 3 again so we get the same relative position in the arrays. Important thing to note here is you cannot sort these lists. If you sort either one of these lists, this statement here will be incorrect. And you cannot sort them separately either. This will sort alphabetically, this will sort numerically. So you cannot sort either of these lists at all. You must leave them as is. Something important to note when you're doing this dual array with a single element access method. So let me run this, and hopefully I didn't make any typos this time, and I did not, which is nice. So we see Alaska, 1, 2, 3, 0, 1, 2, 3, has a population of 720,000 people. 1, 2, 3, 4, or 0, 1, 2, 3. So we can use the same index, in this case 3, to access both elements of the arrays. Now, if we had made this a variable, which we can do, index equals, we'll give it 5, or 5 this time, or 6. And we can change this 3 to a state index, and this to a state index, and run it, and we should get 0, 1, 2, 3, 4, 5, 6, Utah. Let's see what Utah has. And I forgot the semicolon. Let's fix that. And there's Utah. So you could see we can use the same element, same index to access multiple array elements and get the appropriate values. So lastly, just some final thoughts here. We have array size and array length. The array size for Java is theoretically it's about 2.1 billion elements. If you need an array over 2.1 or around 2.1 billion elements, you probably shouldn't be using arrays. You probably should use other data structures, which will be introduced in more advanced classes. The length property is not a length method. So unlike strings where I had the length method with the parentheses, the length property of an array does not have that. Once an array is set and created, that is its size. You cannot make it bigger or smaller. An array is an array and it stays that size for its life. And when you go to count the elements in the array, they include both null and non-null characters, which you'll see when we get into more of a string and character processing. Okay, so that's it for this part of the arrays. So I will go ahead and post this video and these notes in the content section so you can reference it. And that's it for now. Any questions, feel free to reach out. Thank you.